This video will discuss the links that can be drawn between melatonin and ASD. According to the DSM-5, the leading book in the classification of mental disorders, autism spectrum disorder, ASD for short, is a neurodevelopment disorder characterized by impairments in social communication, limited patterns of interest, and stereotypic and repetitive behaviors. Curiously, many ASD patients also experience characteristic sleep disturbances all throughout their life, with the sources of these not being widely known by the public and only partly understood by experts themselves. Cuomo et al. Have estimated the propensity of insomnia in kids with ASD to be from 50% to as high as 80%, which is worrying for a condition affecting so many. Following the work of Chamberlain and Herman, multiple subsequent studies have reported lower levels of melatonin secretion as well as circadian rhythm imbalances in ASD patients. In order to understand how low melatonin may be the key to explain sleep irregularities in people with autism, the metabolism and role of this hormone must be detailed. Melatonin is produced by the pineal gland situated in the center of the brain under two main conditions: when light stops coming into our eyes and when our endogenous circadian rhythm, a sort of master clock located in the suprachiasmatic nucleus, which dictates our sleep-wake cycle, goes into night mode. Melatonin not only helps people go to sleep, it is also essential for thermoregulation, metabolism, and early neural development, which brings us to our next point. The secretion of melatonin is essential to the presence of REM sleep, a phase of sleep characterized by rapid eye movements, which refines the brain connections already made throughout the day. Lack of melatonin lengthens non-REM sleep, a phase characterized by slow, even non-existent movements, which only form new connections, without really pruning the ones that are unnecessary. Imbalances in the different sleep cycle phases are sources of brain fog and numerous other symptoms of sleep disorders. These findings only reinforce the importance of sufficient melatonin production. Research done by Pagan et al. Showed that melatonin deficiency in utero could contribute to the development of prenatal ASD. 6-SM, a derivative metabolite of melatonin, was found to be significantly lower in mothers with children who are diagnosed with ASD. Animal models also show similar findings, with Tian et al.'s rat study being one of the more interesting ones. They injected rats with valproic acid in order to chemically induce autism and then recorded their activity. The rats who had symptoms of autism were engaging in more antisocial behavior, and their hippocampi showed significant impairments in neuron size and dendrite formation compared to the healthy controls. Interestingly, these negative effects were reversed by the introduction of melatonin into their system. Abnormalities in melatonin levels can also be seen in nocturnal urinary levels as measured by Torgman et al. Not only was melatonin presence lower in the urine of young people with ASD compared to the control, but the percentage of melatonin itself was negatively correlated with subsequent measures of impaired social play, impaired verbal expression, and symptom severity. The less melatonin there was, the more impaired the children and adolescents were. It's important to state that all of the points about ASD and melatonin have only been mere correlations up to this point, and the causal mechanism between these two concepts is still being researched. One of the most promising theories on the causal mechanism between melatonin and ASD is the evidence of impaired AANAT and ASMT activity in ASD patients. These two enzymes metabolize serotonin into melatonin. Thus, high serotonin coupled with low melatonin concentrations, as well as low ANT and ASMT activity, are further proof of the possible causal relationship. Because of these links between melatonin and ASD, multiple experts have recommended the use of melatonin in the treatment of not only impaired sleep, but ASD symptom severity as well. Melatonin is a cheap, accessible form of natural medication which shows little to no negative side effects in the general population, including ASD patients, making it an ideal form of first-line pharmacological therapy. Clinical trials on melatonin to lessen the negative symptoms of ASD, like the one from Schroeder et al., have been positive, seeing improvements in sleep, lessening of problematic behaviors, proactive communication, and caretaker quality of life, an aspect that is often neglected. However, it is still important to take into account individual variability in biochemistry, dosage effects, and environmental influences in order to minimize the possible confounding variables ever present in the clinical field. I hope the relationship between ASD and melatonin is a little clearer to everyone.